Have you ever wondered why the universe is so perfectly tuned for life? Is this incredible precision just a coincidence, or is there a greater force behind it? The universe is a vast collection of subatomic particles that come together to form everything we know. From the atoms that make up the air we breathe to the cells in our bodies, everything is made of fundamental particles. But how do these particles organize themselves to create the complexity we see around us? Let's start with protons and neutrons, which form atomic nuclei. They are made up of quarks, and these particles interact through the fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each of these interactions plays a crucial role in the creation and maintenance of the universe as we know it. For example, the strong nuclear force holds the quarks together inside protons and neutrons, while the weak nuclear force is responsible for processes like nuclear fusion in the Sun, which generates the vital energy for life on Earth. Without these precise and coordinated interactions, the existence of life would be impossible. But is this all just a coincidence? Or is there a design behind this cosmic perfection? When considering the origin of the universe, the existence and interaction of these subatomic particles make us question whether all this could be mere chance. The precision with which these forces operate suggests fine-tuning that many see as evidence of intelligent design. It's fascinating to think that, from the smallest quarks to the largest galaxies, everything is interconnected by consistent physical laws. This complexity leads us to explore the history of the universe and how it evolved to become what it is today. Since the birth of the universe in the Big Bang, approximately 13.8 billion years ago, to its continuous expansion and evolution, the history of the universe is a testament to the incredible precision of the fundamental laws of nature. This initial cataclysmic event launched all the matter and energy that make up the cosmos, laying the foundation for the formation of stars, galaxies, and planets. The creation of the universe, from this initial point, depended on a delicate balance of physical constants that govern everything around us. Over billions of years, the universe has gone through various phases of development. From the initial singularity, it expanded and cooled, allowing the formation of the first atoms and molecules. This continuous process of evolution resulted in the complexity we see today, with the formation of stellar systems and galaxies. The precision of these laws and physical constants is evident at every stage of this evolution, as any slight variation could have made life impossible. This stability makes us question whether the universe is really a product of chance. The history of the universe is a cosmic dance where each movement is guided by precise and immutable physical laws. The creation of the universe and its evolution into a state that allows intelligent life is a phenomenon that defies the logic of chance. This delicate balance raises profound questions about the purpose and origin of the universe. Could all this be a mere coincidence? Or is there an intelligent design behind this cosmic perfection? The perfection of the universe is one of the most intriguing and fascinating aspects of cosmology. Physical constants such as the force of gravity, the charge of the electron, and the speed of light are precisely tuned to allow the existence of life. If any of these constants were slightly different, the universe would be an inhospitable place, incapable of sustaining the complexity we see today. This harmony leads us to question whether we are facing a universe too perfect to be the result of chance. This precision of physical constants raises profound questions about the origin of the universe. For example, the gravitational constant is precisely strong enough to keep planets in orbit but not so strong as to crush all matter into a compact mass. The cosmological constant, which regulates the expansion of the universe, is also finely tuned to allow the formation of galaxies and stars. These examples show how small variations could have drastic consequences, suggesting that the universe appears to be finely tuned for life. The idea that the universe is perfectly tuned challenges the notion that everything could be a mere accident. Many scientists and philosophers see this as an indication of intelligent design, a greater force that orchestrated the creation of the universe with a purpose. However, others argue that this can be explained by theories such as the multiverse, where countless universes exist with different configurations of physical constants. This question continues to fuel heated debates and scientific research. In antiquity, the view of the universe was centered on the Earth. The geocentric model, which placed the Earth at the center of the cosmos, was the dominant belief for centuries. This model was formalized by Ptolemy and was widely accepted because it seemed to align with visible observations of the sky. However, this view of a perfect universe where everything revolved around the Earth was challenged by new observations and theories over time, leading to a revolution in our cosmological understanding. The heliocentric model, proposed by Copernicus in the 16th century, was a watershed moment in astronomy. It suggested that the Sun was at the center of the solar system, not the Earth. This theory was initially controversial but gained support with Galileo's observations, who used a telescope to discover moons orbiting Jupiter and phases of Venus, evidence that could not be explained by the geocentric model. These discoveries were fundamental in changing our view of the universe and recognizing the harmony of the physical laws that govern celestial bodies. Galileo's discoveries and Copernicus's theories marked the beginning of a new era in understanding the universe. The transition from the geocentric to the heliocentric model exemplifies how science evolves through observations and challenges to established beliefs. This change in perspective helped us see the universe as a vast and harmonious system, governed by consistent and precise physical laws. From these foundations, let us now explore the more modern discoveries about the expansion of the universe and how this shapes our current view of the creation of the cosmos. In the early 20th century, the discovery of the expansion of the universe revolutionized cosmology. Edwin Hubble, observing distant galaxies, noticed that they were moving away from us, indicating that the universe was expanding. This discovery was a significant milestone because it suggested that the universe is not static but dynamic and constantly changing. The creation of the universe, in this context, could be seen as a continuous event, with the cosmos expanding from the Big Bang to the present. The Big Bang theory, developed from Hubble's observations, proposes that the universe began with a massive explosion approximately 13.8 billion years ago. This initial event launched all the matter and energy that make up the universe, starting a process of expansion that continues today. The cosmic background radiation, discovered in 1965, provided additional evidence for this theory, showing the residual heat from the Big Bang. The precision of these discoveries reinforces the idea of a universe governed by consistent physical laws. But the expansion of the universe not only confirms the Big Bang theory, it also makes us question the future of the cosmos. Will the expansion continue indefinitely, or will there be a point of contraction? These possibilities are profound and continue to be the subject of intense study. Understanding the expansion of the universe helps us appreciate the cosmic perfection and precision of the laws that govern its evolution. The anthropic principle suggests that the universe must have properties that allow the existence of intelligent observers like us. This idea can be divided into two main interpretations, weak and strong. The weak interpretation states that the universe is compatible with our existence because we are here to observe it. In other words, we can only exist in a universe that allows our existence. This view leads us to consider how physical laws seem perfectly adjusted to enable life. The strong interpretation of the anthropic principle goes a step further, stating that the universe must have properties that allow the emergence of intelligent observers. This suggests that the universe is not only compatible with life but is structured in a way that ensures life can emerge. This perspective raises the question of whether there is an underlying purpose in the creation of the universe. The precision of physical constants, which allow the formation of stars, planets, and suitable conditions for life, seems to support this idea of a tailor-made universe. The anthropic principle provokes intense debates among scientists and philosophers. Some argue that it is a way to explain the apparent coincidence of cosmic perfection, while others see it as evidence of intelligent design. Regardless of the interpretation, the anthropic principle forces us to reflect on our own existence and the nature of the perfect universe we inhabit. Throughout history, philosophers and scientists have debated the nature of the universe and the origin of life, each bringing unique perspectives to this discussion. Some philosophers argue that the universe has always existed in a state of equilibrium, a view that resonates with the idea of an eternal and immutable cosmos. Others, inspired by modern physics, see the universe as having a definite beginning, emerging from a point of singularity, the Big Bang. This debate between eternity and creation continues to challenge our minds. Modern science, with its discoveries about the expansion of the universe and the cosmic background radiation, strongly supports the theory that the universe had a specific beginning. However, the question of how and why the universe emerged remains a mystery. While quantum physics suggests that the universe may have spontaneously arisen from a quantum fluctuation, many still wonder what triggered this event. This intersection between philosophy and science helps us explore questions that go beyond the limits of empirical observation. Philosophical and scientific debates also extend to the idea of purpose and design in the universe. Was the universe created with a specific purpose, or are we merely a product of random processes? This question touches on the heart of the anthropic principle and theories of intelligent design. As we ponder these questions, we consider not only the physical laws that govern the cosmos but also the possible intentions behind the creation of the universe. Developed in 1948 by Fred Hoyle, Thomas Gold, and Hermann Bondi, the steady-state model proposed that the universe is eternal and maintains a constant state of density by continuously creating new matter as it expands. This theory was an attempt to explain the creation of the universe without a definite beginning, suggesting that new galaxies are always forming to fill the space left by expansion. The idea of an infinite and unchanging universe was appealing to many because it avoided the need for a point of origin. However, the steady-state model faced serious challenges with the advancement of cosmological observations. The discovery of the cosmic background radiation in 1965 by Arno Penzias and Robert Wilson provided strong evidence for the Big Bang, showing the residual heat of the creation of the universe. This discovery was a fatal blow to the steady-state model, as the cosmic background radiation was inconsistent with the idea of an eternal and unchanging universe. The accumulated evidence over time consolidated the Big Bang as the predominant theory. Although the steady-state model has been largely abandoned, it played an important role in the evolution of cosmology. It stimulated debates and research that led to a better understanding of the universe and its origins. The idea of an eternal universe still resonates in some modern theories, such as the multiverse, where multiple universes may exist in different states. The multiverse theory is one of the most intriguing ideas in modern cosmology. It suggests that our universe may be just one among countless other universes, each with its own physical laws and fundamental constants. This idea expands our understanding of the creation of the universe, proposing that the Big Bang was not a unique event but part of a continuous process that creates multiple universes. Each of these universes may have different configurations, some of which could allow for the existence of life, while others would be completely inhospitable. The existence of multiple universes could explain the impressive precision of physical constants in our universe. According to this theory, our reality is just one among many where conditions are suitable for the development of life. This concept, often called anthropic selection, suggests that we are here to observe the universe precisely because we live in one of the rare universes where conditions are perfect for life. This challenges the notion that cosmic perfection is unique and planned, presenting it as a natural consequence of a vast multiplicity of universes. Although the multiverse theory is still in the realm of hypotheses, it offers a fascinating explanation for the origin of the universe and its perfection. The idea that there are countless parallel universes leads us to reconsider our position in the cosmos and the possibility of other realities with different physical laws. This perspective broadens our understanding of the perfect universe and challenges us to explore the laws of physics even more deeply. The universe we inhabit is governed by consistent physical laws that allow the formation of stars, galaxies, and eventually, life. Gravity, for example, attracts matter in a predictable way, allowing the formation of celestial bodies and keeping planets in orbit. The electromagnetic force holds atoms together and enables the chemical reactions essential for life. Without this consistency in the laws of physics, the complexity we see in the universe simply could not exist. This precision is one of the reasons why the universe is seen as perfectly tuned. Small alterations in any of these laws could have catastrophic consequences. If the gravitational constant were slightly stronger or weaker, stars could not form or would form in an unstable manner. Similarly, changes in the electromagnetic force could prevent the formation of complex molecules, making life impossible. This sensitivity of physical constants suggests fine-tuning that many consider indicative of intelligent design or at least a highly selective process. The consistency of physical laws also allows predictability, which is fundamental to the development of science and technology. Our ability to understand and manipulate these laws enables us to create technology, explore space, and understand the nature of the universe. The precision with which these laws operate is a testament to cosmic perfection and leads us to question whether all this could be just a chance occurrence. The many worlds theory, an interpretation of quantum mechanics, suggests that all possible outcomes of quantum measurements are realized in some universe. According to this theory, every time a quantum decision is made, the universe splits into multiple realities, each representing a different outcome. This means that there are countless parallel universes, each with its own versions of historical events, physical laws, and conditions for life. This theory expands the idea of the multiverse and offers a fascinating explanation for the creation of the universe and its perfection. Quantum superposition, where a particle can exist in multiple states at once, is the basis of this theory. When an observation is made, the superposition collapses into a single state, but in other universes, the alternative states continue to exist. This creates an infinity of parallel realities where every possible configuration of physical constants is explored. The many worlds theory suggests that the fine-tuning of constants in our universe is just one of many possible variations, reinforcing the idea of a multiverse with infinite possibilities. Although the many worlds theory is still a hypothesis and difficult to test empirically, it offers an intriguing view of the nature of the cosmos. The possibility of multiple universes coexisting leads us to reconsider our understanding of reality and cosmic perfection. If all possible universes exist, then ours, with its ideal conditions for life, is just one part of this vast panorama. This perspective challenges our notions of chance and design, inviting us to explore more deeply the mysteries of the creation of the universe. And so, we come to the end of our fascinating journey through the perfection of the universe. We have explored from subatomic particles to vast galaxies, discovering how every aspect of the cosmos is perfectly tuned to allow for life. We discussed intriguing theories such as the Big Bang, the anthropic principle, and the multiverse, all offering different perspectives on the origin of the universe and its impressive harmony. What we learned today is that the precision of the physical laws governing the universe raises profound questions about chance and design. Is all this the result of an extraordinary coincidence, or is there intelligence behind the creation of the universe? Regardless of the answer, this quest for understanding inspires us to continue exploring and questioning the nature of reality. Science and philosophy walk hand in hand in this investigation, revealing that knowledge is an endless journey. If you enjoyed this video and want to continue uncovering the mysteries of the cosmos, don't forget to subscribe to our channel and turn on notifications. Join us on this incredible adventure through space and time, and let's keep exploring the secrets of the universe together. See you next time.